Every year, millions of tons of fruits, vegetables, grains, herbs, and spices are lost after harvest, not because they were grown poorly, but because they spoil before they can be stored or sold. In many parts of the world, farmers rely on open-air drying, spreading their crops under the sun. Although this method has been used for centuries, it comes with serious problems. Dust, insects, birds, sudden rain, and uneven drying can all reduce the quality of the final product. But what if sunlight alone could preserve food faster, more cleanly, and without using any electricity or fuel? That is exactly what a solar dryer is designed to do. At first glance, a solar dryer looks like a simple enclosed box with a transparent cover and a small chimney. It has no electric motor, no heating element, and no fan in many basic designs. Yet it is capable of removing large amounts of moisture from food, using only the natural energy of the sun. The secret is not simply the heat from sunlight, but the way the entire system controls airflow, temperature, and humidity to create the ideal drying environment. To understand how a solar dryer works, imagine freshly harvested fruit or grains being placed onto trays inside the drying chamber. These trays are usually made from food-safe mesh or perforated material, allowing air to flow freely around the product. Instead of piling the food into thick layers, it is spread evenly across the trays. This increases the surface area exposed to warm air and allows moisture to escape more efficiently. Once the food is inside, the transparent cover begins playing its role. Sunlight passes through this clear surface and reaches the dark interior of the dryer. Dark materials absorb much more solar radiation than light-colored surfaces. As they absorb this energy, they begin converting sunlight into heat. The air trapped inside the chamber gradually becomes warmer than the surrounding outdoor air. This warming process creates one of the most important forces inside the dryer. Warm air is lighter than cool air. As its temperature rises, it naturally begins to move upward. This movement happens without any mechanical assistance. It is simply a result of natural convection, one of the basic principles of physics. As the warm air rises through the drying chamber, it passes over the food placed on the trays. At this point, the drying process truly begins. Every fruit, vegetable, grain, or herb contains water inside its cells. When warm, dry air flows across the surface, some of that moisture begins evaporating. The water changes from liquid into water vapor and mixes with the moving air. Gradually, moisture is drawn out from deeper inside the food until it reaches the surface, where it also evaporates. This continuous movement slowly reduces the moisture content of the product. But simply heating the air is not enough. If the moist air remained trapped inside the dryer, drying would slow down dramatically. Air that is already full of moisture cannot absorb much more water. That is why the system must constantly replace humid air with fresh, drier air. Fresh outside air enters through carefully designed openings near the bottom of the dryer. Because warm air is continuously rising toward the top, it creates a slight pressure difference inside the chamber. This naturally pulls cooler outside air inward. The incoming air is then heated by solar energy before moving upward through the trays. As it travels, it absorbs more moisture from the food before continuing its journey toward the top of the dryer. Many solar dryers include a chimney at the upper end of the system. Although it may appear to be a simple vertical pipe, it performs an important function. As the air inside the chimney becomes warmer, it rises even faster, increasing the natural draft. This stronger upward movement helps remove moist air more efficiently, while simultaneously drawing additional fresh air into the dryer. The result is a continuous cycle of airflow powered entirely by the sun. This continuous circulation is one of the reasons solar dryers perform much better than traditional open-air drying. Instead of allowing humid air to remain around the food, the system constantly removes it. Lower humidity inside the drying chamber allows evaporation to continue at a steady rate, making the drying process faster and more uniform. Another major advantage comes from protection. Food drying in the open is exposed to insects, birds, rodents, dust, leaves, and sudden weather changes. Even a brief rainfall can undo hours of drying by adding moisture back into the product. Inside a solar dryer, the transparent enclosure shields the food from these external contaminants while still allowing sunlight to provide heat. The result is cleaner, safer, and more consistent food preservation. Temperature control is also important. Drying is not simply about making food as hot as possible. Excessive temperatures can damage vitamins, change color, reduce flavor, or even cook the product instead of drying it. A properly designed solar dryer maintains temperatures high enough to remove moisture efficiently, while remaining gentle enough to preserve food quality. The exact temperature depends on the design of the dryer, the weather, and the type of product being dried. Different foods require different drying conditions. Thin herbs can dry relatively quickly because they contain less water and have a large surface area. Fruits such as mangoes or apples require more time because of their thicker structure and higher moisture content. Grains often need careful drying to prevent mold during storage, while avoiding excessive heat that might reduce seed quality if they are intended for planting. As drying continues, the moisture content of the food gradually decreases. This reduction is much more important than many people realize. Microorganisms such as bacteria, molds, and fungi require water to grow and reproduce. By removing enough moisture, the solar dryer creates conditions where these organisms struggle to survive. This greatly extends the storage life of the food without requiring refrigeration. Lower moisture also reduces the activity of many natural enzymes inside fruits and vegetables. These enzymes normally continue changing the food even after harvest, affecting flavor, texture, and appearance. Slowing these reactions helps preserve quality during storage. One common question is why a solar dryer works even without direct sunlight shining on every piece of food. The answer lies in the heated air rather than the sunlight itself. Unlike traditional sun drying, where products are left fully exposed, a solar dryer mainly relies on warm, moving air. The sunlight heats the air, and the air performs most of the drying work by carrying moisture away from the food. The design of the trays also plays an important role. Air must be able to flow above, below, and around every layer of food. If products are stacked too closely together, airflow becomes restricted. Some pieces may dry quickly, while others remain moist. Proper spacing allows drying to occur more evenly throughout the chamber. Weather conditions naturally influence performance. On bright sunny days, higher solar radiation produces warmer air and stronger natural airflow, accelerating the drying process. During cloudy weather, less solar energy enters the dryer, reducing temperatures and slowing evaporation. However, even under less than perfect conditions, enclosed solar dryers often continue performing better than completely open-air drying because they retain heat more effectively and protect the food from contamination. Several different solar dryer designs exist around the world. Direct solar dryers allow sunlight to enter the drying chamber itself. Indirect solar dryers first heat air inside a separate solar collector before sending that warm air into a shaded drying chamber. Mixed-mode dryers combine both methods to improve efficiency. Although their layouts differ, all of them rely on the same basic principles: solar heating, natural airflow, and continuous moisture removal. Larger commercial systems sometimes include solar-powered fans to increase airflow. While these designs use small amounts of electricity generated from solar panels, many traditional solar dryers operate entirely without electrical power. They depend only on physics and intelligent engineering. For farmers, solar drying offers significant economic benefits. Crops that might otherwise spoil during harvest season can be preserved and stored for months. Instead of selling immediately when prices are low due to oversupply, farmers may choose to store dried products and sell them later. Drying also reduces weight and volume, making transportation easier and often less expensive. Solar dryers are also valuable in remote communities where electricity is unreliable or unavailable. Because the system relies primarily on sunlight, operating costs remain extremely low after installation. There is no fuel to purchase, no heating element consuming electricity, and very few moving parts requiring maintenance. Of course, solar dryers also have limitations. They still depend on weather conditions, and drying speed decreases during prolonged cloudy periods. The capacity of a dryer is limited by its size, and different foods require different drying times and temperatures. Careful management is necessary to achieve the best results and avoid over-drying or uneven moisture removal. Despite these limitations, solar drying remains one of the simplest and most sustainable food preservation technologies available. It combines basic scientific principles with practical engineering to solve a problem that has challenged agriculture for centuries. By using nothing more than sunlight, controlled airflow, and thoughtful design, It transforms fresh crops into products that can be stored safely for much longer. The next time you see a simple solar dryer standing quietly in a field, remember that it is doing far more than warming food in the sun. Sunlight enters through the transparent cover. Dark surfaces convert that light into heat. Warm air rises naturally through the drying chamber. Fresh air enters from below. Moisture leaves the food and is carried away through the chimney. Hour after hour, this continuous cycle removes water, protects the harvest, and extends the life of food without burning a single drop of fuel or consuming a single unit of electricity. That is how solar dryers preserve food, using nothing but the power of the sun.